Now the second and the third entry types, event and first input, are somewhat similar. They are both instances of the performance event timing interface, and they both deal with latency triggered by certain user interactions. So you'll get the event entry type anytime there's a delay in handling an event. So for instance, say I have a button and this button has a click event handler. Now if there's a blocking task inside this event handler, then it's going to take a while to resolve it, which ultimately creates a delay. The first input entry is kind of similar to the event entry. It deals with FIDs, or first input delays, which basically is the time from the point when a user first interacts with your app to the point when the browser is actually able to respond to that interaction. So to see this in action, I'll create a button and attach a click event listener to it. Inside that event listener, I'll run a for loop, and at the end of the for loop, I'll simply log the number of hits. So I've commented out the elements from the previous example, and now I have a button here. Now if I go back inside the browser and if I click on this button, I immediately get the log message. This means that there was no delay as such. You can actually verify that by going inside this entry. It's of the type first input. So clearly, as you can see here, the processing start and the processing end time is exactly the same. But the start time is a bit less than the processing start. So the start time gets logged in when I click on the button. It takes a very small amount of extra time to start the processing of the event handler, and resolving the event handler essentially takes no time. This is also the reason why you only see a first input entry. You would have seen other entries of type event if there was a significant delay. So let's add some extra zeros to simulate a genuine delay. I'll increase the upper limit of the loop by 1000 times. So let me just add 3 zeros. Now if I go back and click on the button, surprisingly I still do not get an event entry. If I open this up, it still says first input as the entry type. So let me add a couple of extra zeros again. And now if I again try to click on this. Alright, now you can see a bunch of entries. The first one is going to be the first input entry, but we need to look for the click event for which we have the for loop event handler. So I'm guessing it's going to be this one. Here you can see that we clicked on the button at almost 2.5 seconds from the page load. The processing started at about the same time and the processing ended at about 4.3 seconds. These other two events that you see here, even though their processing ended fairly quickly, you can see here that the processing start and processing end does not really have that much of a difference. They also had to face the same amount of delay. That's because the click event, the event over here, is what triggered these two events. So they also had to go through the same amount of delay, and you can see that in the duration here. The duration is same for all these three events. So the only time the API considers an event to be causing delay is when the duration is more than 100 milliseconds. Anything less than 100 milliseconds is not considered slow and will hence not be picked up by the observer as an event timing entry. Based on this information that you have now, you can then make a decision to maybe move the calculation to a later part or maybe run it asynchronously without blocking user interaction with the application. Alright, so the next entry now is fairly straightforward. It's the largest contentful paint. This will give you timing information regarding the largest image or text painted on the screen before any user input. So let me just replace this button with the image that we had in the previous example. Now if I go inside the browser, you'll see that we get a largest contentful paint entry. And if I open this, you can see that the load time was 200 milliseconds and it took about the same amount of time to render. The size property here is basically the height times width of this image, and the rest of the properties are more or less the same as we saw in the previous entries. So yeah, if you have a high LCP score, you can think of maybe lazy loading the resource if it's not essential to the initial page load to improve performance. Then we have the layout shift. So when your website is downloading all of its resources, at times some resources might take a while to download. For example, let's say there is a high resolution image on your web page. The rest of the content on your page has been loaded, but this image took a while, and eventually once it got downloaded, it rendered on the page where it was supposed to, but because of that, the rest of the elements have now shifted. So let me show you what I mean by this. So I have a paragraph, an image container, and an image on my HTML page. The image container will get an image after a while. So after 5 seconds, the image is going to be loaded inside this image container. So when this 5-second delay is met, the image below this image container is going to shift out of its place. This shift is called the layout shift, and it's definitely not a good experience. I'll save this and go inside the browser. After a while, you'll see that a new image comes in. And because of this image, the original image that was present in place of this image had to shift below it. You'll also see the layout shift entries that we get here when this shift happened. If I open this, you'll find that most of the entries again are pretty much the same. The value here is going to give you the fraction of the viewport that was shifted. So while the layout shift was happening, 2 events got triggered. So this one gives you a very small fraction of layout shift. If I open the second entry, I believe it's going to give you a larger value. Yeah, you can see here that about 17% of the viewport was affected because of this shift. So basically, higher the value, the more drastic would be the layout shift. Inside the sources property, you'll find the element that was shifted in your application. So as you can see here, this is the node that got shifted because of this new image. Since as you can see here that it's an array, it can have multiple elements based on how they are placed inside your web app. So now if I go back to the example and move this paragraph tag below the image container, now we should be getting 2 items inside the sources property of the layout shift entry. You can see here that the first source is a paragraph node and the second source is going to be the image node. Alright, so the next entry is a no-brainer. It's the long task entry, and as the name suggests, this will cause the observer to push an entry when there's a long task. So any task that blocks the main thread for more than 50 milliseconds is considered as a long task. If I bring back the previous for loop and add in a couple of extra zeros to it, you will see that it takes a while to compute, and since it's on the main thread, any other task like user interaction will be blocked. So I have the for loop here. If I go inside the browser, you will see that we get performance long task timing entries, and you can see here that it took about 2.2 seconds to complete this long task. So this is definitely something that one should avoid. Then we have the mark and the measure entries, and these are a bit different than the rest. Up until now, the performance tracking events used to get automatically fired and we were able to access them. These 2 events are manually triggered by us in our application. These come under the user timing API. So basically the browser has this performance timeline where all these performance entries get logged. All these entries can then be accessed by you to improve performance. But for the entries that we saw up until now, we were not expected to do anything. Those events were picked up by the browser when something particular happened and then pushed to the timeline. But what if you want to measure some part of your application manually? For example, when a user clicks a button or performs a specific task within your application, you want to accurately measure how long it took to run that particular task. So this is where the user timing API comes in. The user timing API is an extension to the browser's performance timeline and helps you to measure and record performance data that is custom to your application. We'll be using the mark and measure events from this API. So mark is available on the performance object, which is part of the window object. It lets you mark a certain action. So we'll use the same for loop for this example. Using the measure event, we'll calculate the time taken for this loop. So right above this for loop, I'll use the performance object, and inside this I have the mark method. Now this mark method will take in a name, so I'll just call it loop started. Similarly, we'll have a mark for loop ended. At the end, I'll console.log performance.measure, and inside this you can pass in 3 items. The first one is the name of the measure, so I'll just call it loop duration. The second and the third items will be the values of the mark entries. So loop Now if I save this and go back inside the browser, after a while, you'll be able to see the first console log, and here you can see the performance measure entry. There are also these two performance mark entries, but these are generated by the Grammarly extension that I have inside my browser. So you need not worry about these two entries. We'll take a look at the performance measure entry. And here you can see that the loop took about 3.5 seconds to run. The start time of the loop was 196 milliseconds. So yeah, you can use mark and measure entries to measure the time that a particular part of your application takes to resolve. The next entry, which is the navigation entry, deals with browser's document navigation events. So whenever a document loads in your browser, there are a series of events that take place in the background. All the information related to these events can be accessed and used to measure any issues or bottlenecks in performance. This chart here from MDN will give you a decent idea of what all sub-events take place when a document gets loaded. I'm not going to go into detail on what these events do. Maybe I can make a separate video in the future explaining this life cycle, but for now, you can refer to the MDN docs, which I'll link in the description. In this image here, you'll also find a resource timing window. So the performance resource timing interface enables retrieval and analysis of detailed network timing data regarding the loading of an application's resource. An application can use the timing metrics to determine, for example, the length of the time it takes to fetch a specific resource, like say an HTTP request or an SVG, image, or a script. It's like a subset of the navigation entry, which is why you will also find a lot of same properties inside this entry. Finally, we have the paint entry that will give you information about paint or render operations during web page construction. When working with paint operations, we focus mostly on either FCP or LCP. We've already looked at LCP, which was the largest contentful paint, so the largest DOM node that got rendered before any user input. FCP is the first DOM text or image content that gets rendered. The data that this API provides helps you to minimize the time that users have to wait before they can see the site's content start to appear. Decreasing the time until these key paint moments makes sites feel more responsive, performant, and engaging for the users. We have looked at all the key performance events that are tracked by your browser during an application's lifecycle. Knowing how to use the performance observer is not the difficult part. Looking at the data and taking decisions on what to add, change, or get rid of is the real task. This was a very brief overview of how you can track different kinds of events and later on do some analysis to improve the overall performance of the application based on the data collected from the API. So try to play around with this tool and see if you can improve any aspect of your application. Apart from that, if you have any doubts or suggestions, do let me know in the comments. And yeah, I'll see you in the next one.